Hello, welcome back. Today we have 867 transpose matrix, where we're given a 2D integer array matrix, and we are to return the transpose of it. And the transpose of a matrix is a matrix flipped over on its main diagonal, switching the matrix's row and column indices. And this is basically our answer here. So given our inputs over here, all we're doing is rotating it or flipping over so that this row goes down this column. This row goes down this column, and this last row goes down this column. So if we look at the indices, taking this example here that we're flipping the row and column indices, if you look, so this is our column 0, or no, row 0, row 1, row 2, and then this is, so everything here is 0, 0, this is 1, 1, this is 2, 2. All right, so this is 0th row, first row, second row. Okay, 0th item, first item, second item. And we can do, this is our 0th column, 1, 2, 0, 1, 2, and 0, 1, 2. Okay, now if we map these over here, you notice that we have over here a 0, 0. That's a different color. Okay, and the result is 0, 0. 4 is at 1, 0. 1, 0 is the flip version of 0, 1. 0, 2, this guy is actually at 2, 0. All we're doing is flipping the rows versus the columns. So if we take this guy, same thing, it's like we're moving it down here and pushing it down. We're flipping it this way and pushing it down. Where this is 0, 1, I'm just going to take the reverse. 1, 1 is the same, and 2, 1. Okay, so instead of 1, 2, 2, 1, we can complete this by doing 0, 2, 1, 2, and 2, 2. Now, if you notice, given the inputs, what we're essentially doing is we're having some values. So that's 1, 2, 3. That's the 0th row. This guy, this is 4, 5, 6. This is 7, 8, 9. 7, 8, 9. And our input looks like it's actually, whereas this is the input, instead it's returning something like this, right? Something like this. That's what this looks like. Okay? And the way we can do this is, let's grab this guy. Okay. So let's say we have this matrix. Then, if we use the zip function, we can take each of the first ones, group them together into an list of its own, then take the second in each, list them together, or group them together in the second list, and then take the last item, group them together into the third list, like so. We can zip it using the matrix. And that gives us essentially the result, which is 147, 258, 369. And all that did was take for given rows, right? These are the initial rows. Instead of going this way, we're taking the 0th item here, grouping them together, so that becomes 147. The 1th item here, grouping them together, 258. And then the last, and grouping them together, 369. And these are individual lists. And we return them all together to get the output. Okay, so we have both ways. Let's quickly run through. The original way was the rows and columns. We're getting the initial dimensions. Let's do that. So this is the size of the rows, this is the size of the columns. Then we can initialize some results, which is flipped. Instead of having R rows and C columns, it'll have C rows and R columns. As in, if it initially comes in with 2 rows with 3 values each, the output will be 3 rows with 2 values each. And to quickly demonstrate, I can use our handy terminal here. So that's our input. Then this becomes our output, where we take the first items from both lists and then group them together here. The next nth item, which is at index 1, 2, and 5, group them together here. The last index 3 and 6, group them together here. Okay, so we have a result. We're going to say the value doesn't matter. Let's say 0 times R for in range of for C. No, for range of C. Right? Okay. Let me just quickly put the result, return, just so we don't throw an error. And that's okay. Okay, so we just wanted to see this. All right, that's good. Now, all we're doing is for a row in range of row, for a column in range of column, the result of flipped version is going to equal the input of row and column. And we're returning the result. We get the dimensions, we initialize the result with the reverse dimensions, where we have the number of rows and number of columns flipped, and then we do the actual value flipping here, then we return the result. Let's submit that. Okay, so this was the original version. Now there is a zip version, which we saw here, which we can directly use here. We're just returning the zip of our matrix input, where we take every nth column and group them together into its new list. So 1, 4, 7 comes into a new list. The next nth item, 2, 5, 8, comes into a new list. And 3, 6, 9 comes to a new list. And then we submit that. That works as well. All right, so you have 2 approaches. Thanks again. This was 867 Transpose Matrix. Happy coding. See you next time.